Bismillahirrahmanirrahim. Assalamu alaikum. So today in this video we will discuss the correlation and what the correlation do in research. It's a very important topic, especially for research point of view, and very broadly used to check the relationship between the variables. So today we will discuss the simple correlation and to evaluate the relationship between the two variables and how we run the correlation using species. So we have three different examples here. One is the traffic density and the accidents. Second is the economic paper and the physics paper. We will check the relationship between these two variables. And the third is price and demand. This is the third example. So we will check the relationship between these two variables. So now let's start, and we analyze this data using the correlation coefficient R. So the first step is to click here, analyze. Next is correlation and bivariate. Okay, so now here we are checking the relationship between the two variables. The first is traffic density and the second is accidents. So these two variables, and let's we check there is any relationship exist, and if relationship exists, what is the strength of that relationship. Okay, so we need here the Pearson, that's very broadly used to test the correlation, is there any significance or not, and the Spearman test. These two tests, we need the two-tail test. Okay, the option here, okay, let's for descriptive statistic we need means and standard deviation. So just continue, and okay. So this is the output. Here is the traffic density, that mean is 55.55, and accident is 13.66. Okay, and this is the standard deviation for the traffic density, and this is the 11.98958 is the standard deviation for the accidents, and we have 9 number of observation in both data sets. Okay, now here the correlation is the Pearson. If we look at 0.97, that's a very highly strong relationship exists between the variables. So 0.977, that's 0.97 is very close to 1. So there is nearly perfect relationship exists between the two variables, that traffic density and accident. So this is a linear relationship. And look at these are diagonals, which must be 1. That's 1 and 1. Here is diagonal element 0.977 and 0.977. Here is 0.000 and 0.900. Okay, so the Pearson correlation is showing that these variables are highly significant. There is a relationship exists between the two variables, while 0.997 is showing us that the relationship is a highly strong relationship between these two variables. Okay, now this is a p-value. Significance two-tail is a p-value 0.0001, which is quite very small values at less than 0.05. So a highly significant difference that exists between the two variables. They are strongly correlated. Okay, now let's see the non-parametric correlations, that the Spearman's rho. Okay, traffic density here is 0.996. So this test is also showing us that a highly strong that nearly perfect relationship exists between the variables. And if we look at 0.0001, so this is the p-value, which is quite less than 0.05. So a strong nearly perfect relationship exists between the two variables. So this was the first example, and now let's check the test second. That's the economics paper and the physics paper. Okay, so just again the analyze and we just correlate bivariate. Okay, now we shift it back from the analysis box, and now let's economics paper and physics paper. Okay, the same we need Spearman's, Pearson's, and that's two of a significance and means and standard deviation, which I already marked. We need this, and just look at now. Okay, so this is the economic and the physics papers. That's the mean of economic paper 49.5833. That's the standard deviation 13.52075 and 12 observations. Here is the physics paper, mean is 54.0833, while the standard deviation is 11.27716 and 12 observations. So now just look to the correlation tables. That's Pearson correlation. So look at here is minus 0.609. So this is we have a negatively the variables is correlated. Okay, here is 0.03. So this is here is a significant that's less than 0.05, while the minus 0.609 is showing us that there is a strong negative relationship exists between the two variables. So this is like the one variable is increases, so the other is decreases. So this is a minus 0.609. That is a strongly negative relationship exists between the two variables. We can say it's a moderate because it's not greater than that's not less than minus 0.70, which normally we say that if the value is less than 0.70 minus 0.70, so we consider that a strong negative relationship. But at minus 0.60 is also there is a relationship exists, but the nature of the relationship is negative, while the strength of the relationship is moderate. It's not a high, but it's a moderate. So just a look, one look to the Spearman's rho. That's a non-parametric test where we need no assumption in such a test in non-parametric. So here is look at this is a minus 0.609. So here is almost the same value. That's a moderate relationship in strength, and the relationship is also significant because the value is less than here 0.036. That's a p-value which is less than 0.05. So there is a moderate relationship, moderate correlation exists between the two variables, and also a significant relationship. Okay, so this was example. That's the correlation between the economic and physics paper, and now just we check the price and demand. That's another example. So we want to check the correlation between the two variables. So again, we look at the analyze, and that's the correlation bivariate. Okay, we shift it back because we need now to compare the price and the demand. Okay, so that's means and standard deviation. We need Pearson, which is already marked, and Spearman, that's already marked, a two-tail test, and just okay. Okay, so look at here, the mean is 7.5, that's the price, and demand is 17, that's the standard deviation is 3.02765 for price, and 10 observation are there. But demand we have 17 is the mean, 5.98145 is the standard deviation, and we have the 10 observations. Okay, Here is minus 0.97 as a strong, nearly perfect negative relations. So if the price is increases, the demand is decrease. So more price, less demand, less price is more demand. So they are highly correlated. But here is, look at the significance. It's a very highly significant. These both have very strong correlation exists between, but the strength of the relationship is very strong, perfect, while the nature of the relationship is negative. Look at this minus 0.976. It's mean if the price is increases, how much they are increases, so much the demand will go down. So less price, more demand, more price, less demand. So this is 0.000 is a p-value, that a highly significant value. That's a Pearson test. Now just a look to the non-parametric correlation. Correlation Spearman's rule. Okay, price is 1 minus 0.997. It's a negative relationship. That's nearly perfect because it's very close to minus 1. So now if the result of the correlation R value is minus 1, so there is a perfect relationship exists. But the negative sign indicate that the relationship is negatively correlated. So strong relationship and negatively correlated. So that's very significant. Look at the two-tailed test. The p-value is very simple. Okay, so this was the video how in SPSS we can run the correlate. How is the analysis on the correlation that we consider these 6 variables: traffic density, accidents, and that's economics paper, physics paper, these 2 variables in prices, and demand, that's the other 2 variables. We give a look to the correlation here. That's the correlation is used to check whether there is a linear association exists between the variables. 2 random correlation analysis demonstrate how to determine the nature and strength of the relationship between the 2 variables. When the variable is time dependent, it is known as autocorrelation. So this is the correlation. That's a correlation we are using to check the nature and the strength. Nature is that negatively correlated or positively correlated. Strength of relationship, how the variables are strongly correlated. Okay, this is the correlation coefficient. So little bit about the correlation coefficient. That's range from +1 to -1. If R is 0, there is no relationship exists. If R is 1, there is perfect linear relationship between the variables. And if R is -1, there is a perfect relationship between the variables, but that's negative. Look at the graph. This is a linear relationship. That's a perfect positively correlated. That's increasing linearly. Okay, that's -1 R. That decrease. That's decrease linearly. That's a strongly negatively. That's a perfect negative relationship exists between the 2 variables. Okay, so that's a positive relationship. Both are increases or both are same decreases. That negative relationship, one increase, the other decrease, one decrease, the other increase. No relation, R is 0. Perfect relation, R is equal to 1. There is a perfect relationship. That's a type 2 linear relationship, non-linear relationship. Linear is important because it will provide its simple concept of the relationship. It's easy to understand the variables. If they are linear, if they are non-linear, there is problem, a complication to understand the nature of the variables. Okay, so now type 3, that's a simple correlation when one independent, one dependent variable, multiple correlation when there are one dependent and two or more, that's independent variables. Okay. That's how to find the correlation coefficient we use in species. That's Spearmint rank correlation method, Carl-Pearson correlation methods. These are the way. These are the tests we use for analysis of correlation coefficient. Okay, that's the equation that we are using to find the correlation coefficient, the strength of relationship, the nature of relationship. That's actually the equation we use to find the correlation coefficient. That's important. That's if R is greater than 0.70 or R is less than minus 0.70, relationship is strong. That's R is 0, no relationship exists. If R is 1, perfect positive relationship. If R is minus 1, perfect negative relationship. If R is less than 0.70 or R is greater than minus 0.70, moderate relationship exists. So I hope you have got a little bit idea about the correlation. What is the correlation? What do the correlation do for us in research? So thank you very much for watching video.